Okay. Good. Hello, hello. Hi, everyone. Welcome to NDC Security. This is my first talk here, and you are in the GitHub Actions talk. I'm lucky that I got this talk after lunch, so hopefully you're okay on food, but if you feel sleepy, don't worry. I'll try to speak loud and give some demos, so make this entertaining as much as possible. This talk is about GitHub Actions, vulnerabilities, attacks, and countermeasures, right? So this is part of a research that I've done last year on GitHub Actions, and that's what I'm gonna talk about today. We're gonna see some overview of GitHub Actions, some security issues, and then we'll dive deep into the attacks. And of course, since this is a developers conference, I'll provide some recommendations or best practices there. So yeah, my name is Magno Logan. I've been in information security for over 12 years now, information security specialist at Trend Micro in Canada, and senior threat researcher, whatever that means. But basically, I do research around cloud and container security technologies. So things like Kubernetes, GitHub Actions, Docker, Jenkins, everything that's related to the cloud, different services from cloud providers as well. We try to analyze those. We do some threat modeling. We find some issues, can be just misconfigurations or even 0 days. We have something very interesting coming up in the next few months. And that's what we do. We publish, we write blogs, we present a conference like this one, and we try to promote this best practice of security, kind of raise the awareness, and of course, help the community and help our customers as well. My background is as a developer. I have a dark side, a dark past. I was a Java developer, so I have to assume that. But yeah, right now, mostly I use Python and still learning Go to do my automation there. I also teach secure coding and DevSecOps since 2011. And that's the company that I'm part of. They're back in Brazil. So I teach this course, Secure Coding and DevSecOps, a 40-hour course. We're launching this year. This course is online, so we're launching that in English as well. So if you're interested, just feel free to reach out to me if you want to learn more about this, the program, what we teach. We talk about different tools, static analysis, dynamic analysis, software composition analysis, all that stuff. But yeah, just reach out to me later and we can talk more about it. Since I've been doing this for a while, and given the situation in the world right now, I just want to say that I always try to give back to the community, and I've been involved with many organizations such as OWASP and the CNCF, the Cloud Native Computing Foundation, doing volunteer work. And one of the things that I do is I help people doing resume reviews and mock interviews. So if you got laid off, or if you're changing careers, if you're looking for another opportunity, and you'd like me to take a look at your resume, I can give you my feedback, provide some comments, some recommendations. I know that the structure of the resume might be different for Europe than it is for Canada and the US, but that's fine. And I also do free mock interviews. So like I put myself in the role of the interviewer, and I interview you mostly on the technical side to understand if you're prepared for a real technical interview. So if you want to do that, also just reach out to me. I don't charge anything. This is kind of my way to give back to the community. One of the ways, one of the volunteer works that I do. Also, this talk is not about GitHub code spaces. That's another topic. But we just launched an article today, 2 days ago, actually, about GitHub code spaces, some of the new research that we're doing, me and my friend Nitesh from our research team. So if you want to take a look at that, That's the QR code or the URL will take you to this article on the Trend Micro website. So this is the agenda that we have today. What is GitHub Actions? Who here has played or has used GitHub Actions before? Oh, wow, that's good. Nice. Okay, so we're gonna talk about understand what it is, how you play around with it. So I won't spend too much time on the introduction, but then we're gonna see how attackers, cyber criminals are abusing the runners, which are the servers that run your automation on the GitHub Action, which basically runs on Azure. We're going to create a malicious action. So we're going to create an action that anyone could be using or leveraging that if I publish to the marketplace, which basically is a place that GitHub has that anyone can publish your action. And what's going to happen if someone uses that malicious action. There are some other attacks. Once I'm inside the environment, once I'm inside the Azure cloud, because that's basically a VM that's runs on Azure, what can I do there? What else can I exploit, right? So we're gonna see that as well. And of course, at the end, talk a little bit about some of the countermeasures, some of the things that are in place that GitHub has improved over the years. This is a fairly new service. It was launched 2019, but there were, given the mass exploitation and exploitation by cyber criminals, there has been some improvement that needed to be done. Feel free to ask questions. Don't mind interruptions. I think it's better to ask the questions while I'm explaining the topic than to go back at the end. So just raise your hand and you can ask your questions. So on this topic, for this talk, there are 2 articles that have been published last year, one in January and another one in July. Just the links are there. Sorry, I didn't make the short links there. I forgot about it. But basically, there's more details, more description. If something I missed here in this talk, you can just take a look there. And there's some special thanks there for people that helped me during this research. So yeah, that's that. Moving on. What is GitHub Actions? Basically, a CI/CD tool or CI service provided by GitHub, right? So if you used Jenkins before, it's basically of course, I'm simplifying this, but it's the GitHub version of Jenkins with, of course, some improvements there. You don't need to run a separate server like Jenkins to do your automation, to do your CI. So if you want to build stuff, run some testing, you can run security testing as well, static analysis, dynamic analysis, whatever you want. You can do everything inside GitHub, and it's available for free. So if you have a GitHub account today, you can do that on your own repo. You can do some automation, and you can even create like a DevSecOps pipeline. I have a repository that does exactly that. It runs some security tools for you. All you have to do is just call this GitHub action. Basically, the GitHub actions are YAML files that you create and you save that in a specific folder in your repository, which is .github/workflows. So make sure there is an S at the end. I made that mistake before and things weren't working and I didn't know what was going on. So just because of that S there at the end. Every time there is an event on your GitHub repository, it can trigger one of or several actions. So it really depends on how you configure. For example, a pull request, edit, you change some file on your repository, everything can be an event. There is a list of events on the documentation there on the website. There is a great documentation from GitHub available. So you can trigger that based on an event. And what that's going to do, that's going to create a VM on Azure, and it's really a VM. At the beginning I thought it was a container, but it's not. That is going to run your automation inside that VM, whatever you want to do. And then after your automation is done, that VM gets destroyed. You don't get access to that VM anymore. So we're gonna see some of the advantages and disadvantages of that. And that VM can be a Ubuntu VM, so Linux, Windows, or even macOS. As I said, it's free for any GitHub account today. Of course, there are some limits, but you can start playing around with that. And I think for you, if you're just trying or learning GitHub Actions, the limits, you're probably not gonna reach the limits unless you're doing something bad, like what we're gonna show here. So yeah, there is an event. So as I said, like a pull request, a push can be, there is a list there on the documentation. This event triggers, creates a runner. It doesn't really create, it's already there. It just assigns that runner to you. And that runner is the virtual machine that's running on Azure. And that runner is gonna run a job. So a job is a series of actions, steps that you can run. Each step can be a command, so a Linux command. It can be a shell script, for example. If you're running on Windows, it can be PowerShell, or it can be another action. So from my action, I can call another action. So there is some relationship there, and there is some dependency as well. And you're trusting that other action, especially if that other action doesn't belong to you, you didn't write that code. So some issues there. Of course, if you have two jobs, you can have another runner running there. So it's going to create another VM, and that's job 2. You can give them names. And of course, like it's shown here, there is some relationship between runner 1 and runner 2. So I can't start runner 2 without runner 1 finishing all the steps, right? They can run in parallel if I want. By default, that's how they run. But like what's shown here, they run in sequence. So one has to finish for the other one. Maybe it needs the output results from the job 1 as input for job 2. So that's a possibility. So why GitHub Actions is getting so much adoption? Why is it getting so much attention for developers? And like, as I saw, more than 50% of the people here are using. There is this marketplace. And if you played with Jenkins before, there's a similar approach with the Jenkins plugins. The marketplace, it's basically a place inside GitHub where anyone can post their actions. So I can write my own action and I can make it available for free or charging something if I want on the marketplace. Anyone can do that today. And this number is probably outdated because I was tired of every time I present this, like changing this number. But if you go there to the GitHub Action Marketplace, that's gonna probably be around maybe 20,000 actions available by third parties, by companies, by organizations, or by anyone, any user. What can you do with these actions in the marketplace? We're talking about security here. So yeah, you can run these tests. You can run DAST, you can run SCA, software composition analysis, SAST, container security, so image scanning. You can do almost like pretty much anything you want, right? So that's great for security perspective, for a DevSecOps pipeline, for some automation purposes. That's awesome, right? Developers should leverage that. So just quick overview or review for those who know it already, how an action works. This is basically action in action. And the example here is a nuclei, the tool nuclei or nuclei DAS scan, right? So a dynamic analysis of a website. So I have it here, the YAML file, basically that's saved on the .github workflows directory of my repository. Here we can see that on the name, and then there is this tag or this directive called on, right? This tells me when this action is going to run, which event is going to trigger this action. So I have two events there. I have a schedule, So based on the cron tab, so I can set it up. I want to run my scan every day, every week, specific time of the day, doesn't matter. Just like the Linux cron tab, I can configure this here. And the workflow dispatch is a specific event that I can trigger that manually. So if I want to trigger the scan right now, I can do that because there is an event allowing me to do that. Then there is jobs, and basically there is only one job called nuclei scan, and it runs on Ubuntu latest. So it's using the latest Ubuntu version provided by GitHub Actions to run the VM to run this action. So it's gonna assign, not spin up. There is already a VM spun up there on Azure. It's gonna assign that to my job, and it's going to run that on the latest Ubuntu version. Some steps here, interesting steps. Uses actions/checkout. So that's not my code. That's not my action. It's using a third-party action inside my script. So here there is some dependency, there is some security issues around that. But for this example, this action is calling this checkout action, which is provided by GitHub, this username/checkout. So if you go to github.com/actions/checkout, you can see the code of this action. So you can analyze that as well. So pretty much all the actions are public repositories on GitHub. The second step here, nuclei scan, this is actually the scan, and that's also a separate action. We can see the target here, the website that it's going to scan, example.com. Of course, I can change that to the URL of my application. Can be a development environment, can be an IP address, whatever it works. And also the last two ones, as I mentioned, after the action is done, I don't have access to that VM anymore. So whatever was generated, wherever was logged, created, or binary was compiled, whatever, if I don't do anything else, I lose access to it. I can't go back and retrieve it. So I need to have some steps that upload whatever was generated during that automation back to my GitHub repository. So basically that's what's doing here. The artifacts, the nuclei logs from the scan, and the output, the .serif output of the scan, right? It's a common extension for SAST and DAST tools created by Microsoft, and of course now GitHub is using it. So this is just an overview of how an action works. So far, so good? Okay, great. So what are the known vulnerabilities? When I started this research back in 2021, these were the known vulnerabilities. There are some blog posts about the GitHub, from the GitHub Security Lab as well, talking about these. Pull requests from forked repos. So when it was released, I'm gonna talk about that in the next few slides. There was this ability of you forking a repository and then making a pull request back to the origin repository, and you were able to change whatever action was there. So you could change to anything. And so basically what attackers were doing is forking a bunch of repos and changing the YAML code of their actions to basically do what? Mine cryptocurrency, right? For free. And that was running inside the origin user, so it wasn't running on the cyber criminal users on GitHub, right? So the kind of the maintainer of that repo got banned or got like the kind of their account suspended from GitHub because GitHub assumed that they were the ones doing the bad stuff. That wasn't the case. We're gonna talk about how to fix this. This basically has been fixed already, and there is some settings on the when I talk about the countermeasures part. So we're gonna see that as well. There's also, just going back to these topics here, there's also the command injection via untrusted inputs. So you can send, of course, You always should validate your inputs. That's kind of the basics of secure coding, one of the basics, right? But there are some fields there from your action that if you send a malicious input and you're reading that on your action, that can cause command injection. And of course, the kind of the main focus of my research was this third part here, the malicious GitHub actions from the marketplace. So yeah, I talk about the forked repos. Let's see how attackers were abusing Windows runners there. So I'm not sure if you can see in the back there, but just look at the last command here, right? They're deploying a Windows machine, Windows latest. We can see that there's some strategy. I'm gonna talk about that later, and there's the steps. One thing there it's uses Nick-vision/retry. I'm not sure if Nick's here. Hi, Nick. But yeah, we're gonna see that the attackers are already leveraging third-party GitHub actions, legitimate GitHub actions, to mine cryptocurrencies. And of course, the last command there is just running their binary, the node.exe. Of course, that's not a node or npm binary. That's the xmrig malicious file, and that's kind of their command to mine cryptocurrencies, the pool, and their username, and all that stuff. So yeah, as I pointed out, they're leveraging third-party GitHub actions already. So the attackers already know how to do that, and instead of writing their own stuff, they know that this is available, and this retry GitHub action. Retry is the action if it fails. So if their miner stops running, it's going to restart, create a new VM and restart the server and keep mining for them. So it's just an automation that they don't need to write anymore, and they're leveraging that. I reviewed that code. This is a legitimate GitHub action for legitimate purposes, but they're abusing that, right? And of course, the node.exe file that we saw in the last command there at the bottom, of course, that's malicious. That's a crypto miner. If you check on various total, yeah, not good. So that was inside the repository. So yeah, not great. Here another example of them abusing another Windows runner, right? Deploying a Windows server on Azure and using that to mine cryptocurrencies. This time, they're leveraging PowerShell. You can see some PowerShell commands at the bottom. And as I mentioned there, the matrix, the strategy there, max parallel from line 7 to 12, what is that doing? Who knows? It's multiple servers, right? At the same time. So of course, if I'm mining cryptocurrencies, I want to get the most out of it. So if I deploy more servers, I'm going to mine more and get more money, right? Because as soon as I'm detected, as soon as GitHub finds out, they're going to shut that down. So if I deploy as much as I can in a short amount of time, then yeah, big like money, free money, right? And yeah, also the last command there deploys the xmrig binary. There is the pool and there is the username, all that stuff. Very similar, very same approach. What is funny is that if you take a look at this code, I found all those repositories, all these is the exact same code as this one. And these were the only ones that I analyzed. There were hundreds of them. And they're all kind of, you can see they're kind of fake usernames. They were created from automation, but they're all called captaincrypto.yaml or something like that. But it's exact the same code. So maybe it's just one person kind of scaling their business or someone copying each other like copycats. Of course, we sent the list of URLs for GitHub to take them down. They took almost a year to take it down. We used the proper channels as was recommended to us, but yeah, some of them might be still available. So I don't know. But yeah, we reported it. Abusing Linux runners. Now I'm deploying a Linux, and I got, like, I'm not a Bitcoin expert, so I got into the discussion while I was doing this research with some of my friends that are, I think they are experts in Bitcoin. Maybe not anymore because it's going down, so we'll see. But yeah, like, what would make someone to choose between a Windows runner or a Linux runner to mine cryptocurrency? They both have the same configuration, and they're both using CPU, not GPU, to mine cryptocurrency. Who can answer that question? Which one would be better, Windows or Linux, in your perspective? Why? Sorry? Oh, it's better? Okay. Yeah, that's a good answer, but yeah. Oh, sure. Yeah. So yeah, the question was, if you're mining cryptocurrency, if you're using CPU and not GPU, and you have two VMs with the exact same configuration, same memory, same CPU power, and all that stuff, which one would be better from a cryptocurrency miner perspective, Windows or Linux? The answer that I got there, okay, Linux is always better. That's, I would suppose so. But yeah, because most the kind of the arguments that I got was correct, Linux, because it has less startup services, it has less services running, and when it's idle, so it's probably gonna run more and exploit more of this crypto miner, right? It's gonna leverage that more. So I haven't tested this theory, but that's kind of the answer that I got. And you can see they're downloading here from, this is the first command, the second command, the second line there, first command, the wget command. This is original Monero crypto miner, XMRig, right? It's available on GitHub, and it's legitimate. If you want to mine cryptocurrencies for legitimate purposes on your own machine, of course, you can. But they're downloading inside the runner that's running inside Azure and mining on for free, right? And of course, just some Linux commands there, unzipping the file, and then, yeah, starting the crypto miner here. And some of them, they're even, I think I cut this when I took the screenshot, but some of these commands, they even put some arguments to limit the amount of CPU that they're using to avoid detection. So they're limiting amount CPU 70, 60% to avoid detection. So there is some arguments that you can use here, and I've seen in some examples, so they don't get easily detected and shut down by GitHub or Azure. So if you visit a repository, and if they're using GitHub Actions, you're gonna see an Actions tab at the top of the repository. And if you go to this tab and you see this red sign there, GitHub Actions disabled for this repository, that's probably not good. That probably means that they're doing something bad and GitHub blocked them from using Actions. But they only blocking the repository, not the user. So if the user creates another repository, then they can do the same bad actions again. So it's like a cat and mouse chase. And of course, if they block the user, they just create a new GitHub user, right? With some automation, it's kind of trivial to do that. So yeah, if you're going to GitHub looking, oh, I might as well use this repository. This tool seems nice. And then you go to the Actions tab and you see this red sign, probably not a good idea, okay? Just kind of a side note to that, another research team at Trend Micro, they published this really great white paper about how cyber criminals are leveraging free services, SaaS services, just like GitHub Actions, to mine cryptocurrencies for other things, and not just GitHub Actions, like Kubernetes, Docker, any cloud, different cloud services. So it has a very detailed analysis of that if you're interested. just the link there. And of course, I'm sharing the slides later, so yeah, no big deal. So there was the issue of the command injection. I haven't explored that issue much. That's on the GitHub Security Lab blog post. But if you can see here, there is a difference between the first action and the second one. So you see the $ at the beginning there. So that might lead to a template injection as well. And of course, command injection. These are the fields that you can manipulate on the left side there. So you can inject malicious commands through these fields. And when the action reads these fields, it can trigger the command injection, right? So I haven't explored that much. That may be an area, if someone wants to dive deep into that and it's interested, we can talk about it. Okay. This is the part that I spent most of my time doing my research, the malicious GitHub Actions. My first thought was, can I create a GitHub action and then provide that available, make it available on the marketplace? And if people use it without knowing, of course, that it's dangerous, right? Will I be able to maybe get a shell inside the runner, right? So when they run in the automation, of course, I will make it unsuspicious. I'll make it credible and like, okay, this is not a malicious GitHub action. But when they're using, then it connects back to my machine, to my C2 server, right? Yes, I can do that. So we're going to see that today. So the problems with GitHub Actions is just the same issues that we have with libraries and dependencies, right? You have to treat this as third party, and you can't trust blindly. You have to take a look. There's ways to look at the code. Unfortunately, I'm not aware of any tools that they're scanning GitHub Actions. I think GitHub is working on that through CodeQL, their tool for static analysis, but I'm not sure how mature that is right now. So yeah, check their code before using, and I'm gonna give some tips as well, as if you're searching the marketplace, there are a few things to look for that can give you an idea that this action might be a little bit better than the others. For example, the blue check mark. I know that's not kind of a seal of, oh, this is safe and this is security. This just verifies the creator of that action. For example, if it's a company, oh yeah, GitHub knows this company. They kind of trust the company, but they're not saying that they scan the code and it's free from vulnerabilities, right? So you still have to be careful here. And of course, as I mentioned earlier, if you see this on your YAML file, you can go to the URL github.com and then /actions/checkout. That's the first, you're gonna see the code of the first action there. If I go to the second one, github.com/actions/setup-node, I'm gonna see the code, what's running when I call that action, right? So I can review that. If I know the code, there's different languages that the actions are supported in, so JavaScript and other things. So if you can read the code, then you can understand what it's doing. If you can't read it, and if you can't trust it, then might be better to not use it. Okay, now the fun part. So I said, okay, I'll create a simple GitHub action, and I use the example available in the documentation there. Okay, hello world, greet someone, okay? But then the first step there, I run my GitHub action and I have /backdoor.sh. I wanted to make it explicit that this was a bad action because I didn't make it available on the marketplace. And of course, if you go to my GitHub and find that repository, you're gonna see that's bad. Don't use it, right? I only made it for research purposes. If you look at what's inside that backdoor.sh, it's basically downloading Netcat, and I'm going to explain why in a second. Making, installing, building, and then connecting back to my C2 machine, my my instance there. And that instance is on AWS. So my GitHub action inside Azure is connecting back to my AWS machine. And I'm gonna do the demo here so that everyone can maybe understand better. So yeah, that's the URL of the fake GHA or GitHub action there. So what happens when I call that action? See the URL there, github.com/Magno Logan/fake-GHA. And here on the left side there, that's what I'm calling, right? The steps uses Magno Logan/fake-GHA. And when I call that, here I'm listening to the port 443, and that's basically me getting the shell back. And I'm gonna do the demo of that. Hopefully, yeah, we'll have time for that, right? So here I can see that I'm running the user, and this is the machine there, Azure, right? Linux, something AZ90 and Azure. And I'm inside an EC2 instance inside AWS. So I'm making that connection. And from there, I can, technically, I'm not allowed to use the GitHub Action Runner to send interactive commands, have an interactive shell. Now I can, right? And I don't need to trigger the action every time to run my testing, right? So I can do everything here. Of course, there is a limit of, I think it's 6 hours for each job. So I have a window of 6 hours to play around with that. That's okay. What else can I do here, right? Once I was inside that VM, that runner inside Azure, what did I do, right? First thing is, okay, is there any other server next to me? Can I do some lateral movement and exploit other servers that might belong to other users, other people, right? So I ran an nmap scan inside the Azure internal network. I did the reverse shell, as I explained, to the external server, my EC2 instance on AWS. But I can also use this as my proxy to trigger attacks from Azure to other servers on Azure, other servers anywhere on AWS, for example. And the source IP address will be the IP address from Azure and not my own. So I'm hiding behind this GitHub action to do malicious things. So I can do that as well. I know it's a bit small here, but this is kind of the nmap scan that I did inside the Azure network. The first result there is my own machine, my own runner, and then the other ones. You can see the ports that are open. There you have, some of them are open or other not. SSH, HTTP, HTTPS, 3389 is, oh man. Yeah, RDP. So yeah, RDP, sorry. And then I have an 8084 there, which is WebSNP. That's not anymore. That got fixed by GitHub, I guess. They removed on the latest versions. But this was an HTTP server, very old HTTP server called Mono XSP, or XSP, I think. And I talk about this on my article there. I don't cover that very much, but it was weird. It was enabled by default, and you even have Nginx and HTTP there, but they're not enabled by default. So why was that enabled by default? And the port was open as well. So there's some tricky things going on. As I checked on the latest version of the Ubuntu Linux, that wasn't enabled by default anymore. Well, that's interesting. And yeah, some of the other machines there, I get their domain name, others I don't. So yeah, there's some tricky other things to maybe dig deeper later. So I didn't have the time to do that. It took me at least 3 months to do the whole research. The reverse shell from the runner. Why am I downloading Netcat from scratch? Netcat is already available on Ubuntu by default. Who can answer that question?
You didn't want to use pipes?
Didn't you want to use pipes? Yeah. No. The version of Netcat that's installed on the Linux machine, it doesn't have the -e option. I don't know if that's what you're...
Yeah, that's what I mean.
Okay, sorry. Yeah. Yeah, it doesn't have the -e option, so I couldn't use that. Yeah. There are other options around it. I figured this, okay, I'll just install from scratch, no problem. Also, when I'm connecting back to my machine there on AWS, I'm using port 443. Why? Okay, yeah. What else? If I use a high port, what would happen? A higher port, say 5,000. Exactly, right? Azure has some egress filtering. They would block this the request. So 443 is allowed. So then my GitHub Action machine inside the Azure network can talk to my AWS machine, my AWS EC2 instance. So yeah, we can see here in the example, right? I showed it earlier as well, the EC2 there IP, and then of course when I get the connection back, I'm on Azure. The pivoting part, right? Since I can do reverse shell from the runners to my servers, I can also issue malicious commands and attack other websites, scanning AWS, scanning Azure, or even outside of Azure. Sorry. Okay, so before we go to the demo, yeah, I think we have time, 20 minutes. Just want to talk about the countermeasures. We talked with the GitHub security team. Some of these things that I mentioned here and that I kind of explore in my research, they're not a bug, they're a feature, right? They're by design. Like, of course, you have access to the machine and you have elevated permissions on that machine that you own or that you deploy while it's available, right? So you have sudo there, you can do whatever you want. So you're responsible for protecting that machine. And you're also responsible for the third-party actions that you run in your code. So you have to validate that as well. So one of the things that I mentioned here, I know it might sound like common sense, but yeah, only use actions from trusted creators, right? So the trusted creator is the check mark there. I think, of course, there are some exceptions if it's a new project, it's something that is just like you're not using for a production environment, you're just validating something, that might be okay. But the trusted creator means that basically GitHub has validated that user and it's not a security analysis, it's not a security scan of that action, but I think it gives a little bit more trust to it. Making sure you set the right permissions for your actions. Some of the actions, if you don't configure that correctly, they will have write permissions to your repository. So if someone compromises that, I can change the whole code on your repository and add anything I want. Like what's happening with the forked repos, similar approach. Do not run actions from forked repos. So you can, I'll show the next slide. There's an option there on the actions permission settings that you do not allow. If someone forked your own repo or the repo from your organization, you don't allow them to run actions if they send a pull request back to your original repo, right? You still have to review it. You don't allow to run that automatically. There is something that I didn't mention here, and I think just because of time, is that every time there is an action that's created on Azure, there's a token related to it, right? There's the GitHub token that gets added to that VM. If I get access to that token as well, so if the attacker compromises that machine, for example, using that malicious actions as I showed, then they can get that token, and while that token is valid, that's basically while the action is running, the VM is active, then they can depending on the permissions of the token, they can even write or read files from the repository, even if it's a private repository. So protect your secrets. There are some options there for you to add secrets properly on your actions. So if you want to call similar to what you have on Jenkins, it's like a kind of a vault approach. So you have your secrets. You don't add secrets, hard code secrets on your YAML files, right? So that's kind of the idea. Don't do that. So here are some of the options there. If you're not using actions, make sure that you disable your actions, the permissions there on your settings. It's for each repository. I think you can do that for the whole organization if you're not using any. So there are some permissions. And of course, the fork pull request, as I mentioned, this is the setting that GitHub added after that incident of the hundreds of forked repos mining cryptocurrencies, right? So this was fixed by this, and I think that's by default. So require approval. If it's a first-time contributor to that repository, it requires some approval to run the action, to run the automation. So that helps. So that's the content. I'll go to the demo, but if anyone would like to ask questions while I'll shift and prepare everything, feel free. Yeah, I'll leave it here, and I'll share the slides as I mentioned. So yeah, let me just go back here. Stop sharing my screen. Go. See if I can go. Where's this? Okay, here. Let me display it now. I think that's better. Let's see. Oops. Should I do something? Okay, now it's better. Okay. So basically, I only use this repo and the other one for the whole research. Let me increase zoom here. And yeah, the GH8-test, I have the workflows and I have 3 separate YAML files. As I mentioned, these are the ones that I use to run the actions. So let's do the first one. The simple one here is this gha.yaml, right? This is just going to run Ubuntu machine. Let me go. See there? Yeah. This is just going to run an Ubuntu machine and execute some commands, reload NDC. So let's see how that works. To trigger that action, the event there is on push. So push means any changes, anything, any file changes to the repository, it's going to trigger that action. So if I edit here this file, I'll just make it easy. NDC, security, I'm just changing the name of the action to trigger. And of course, I'm gonna do something that no developer should do, commit to main, but okay, just for demo purposes. So once I do that, if I go to the Actions tab, I see that there are some actions triggered, and you see that they're queued here. All the 3 actions were triggered at the same time because they're all on push, but we only want to look at the one that I added, which is this one. I can see here the file that I changed, this one. So if I go here, I can see that, okay, it ran at like very fast, and I can see the logs from my action, right? So I can see ID, all the commands that I run, uname -a, env, and of course, hello NDC. So I see the environment variables. These 3 stars here, this is basically my GitHub token. So GitHub has some intelligence to not display my GitHub token. It's basically looking for that pattern, and it's masking that on the logs. Of course, there are some ways around that. If you just base64 encode it, you can read it or show here. And yeah, hello NDC at the end. Okay, my action is working. It's just an example that it works. Now, I want to run the second one. So I'm going to go back just to show you the code. It ran already. So that's the fake one on the marketplace. Yeah, okay. Yeah, I'm not sure if... Let me see. Why is not... Okay, I think that's better. So you can see here on push, jobs, GHA, run Ubuntu latest. And the only step is calling another action, fake GHA. If I go to the other repository, fake GHA. This is on my same username, but it could be on another user. That's fine. And that's the backdoor. That's the same one that I showed earlier, right? Just installing netcat and connecting back to my machine. So if I publish that on the marketplace, and of course I'm gonna make it sound legitimate. I'm not gonna add the name backdoor, and I'll add some code to it. Okay, build your Java application, right? Because of my dark past. So, okay. And then at the end, there is some code that at the bottom can be base64 encoded or something. That's gonna do that for me. If I publish that to marketplace, if someone downloads or starts using that, leveraging that, game over, right? Of course, there's some social engineering involved, but I think that's doable. So if I go back and if I run this YAML, I'm just gonna add it to commit to main to trigger the push event. I could also do that some other way, but it's fine. Okay, start commit to main. Oops, first, let's see, on my EC2 instance, let me just leverage that. Hopefully that didn't start yet. So if I go to the actions, fake GHA here, marketplace. So let's see. Gonna see it's running, and it's gonna keep running because it's gonna try to connect back to my EC2 instance. And see connection received here. If I do ID, I see runner, uname-a. Now I'm on a EC2 and connecting back to my runner on Azure, right? And then I can do all sorts of stuff. And of course, this is the same approach if I wanted to. Let me go back. If I don't publish to the marketplace, if I just want to test it and just run the code, I have another option, another action here, which is the connect back, right? It's the same code, but now inside the same action, not on a third party. So I won't demo that because it's gonna be the same thing, same connection and all that stuff. But here I'm calling them directly. The other one I'm using the third party, right? So if I publish that to the marketplace, of course, for legal and ethical reasons, we didn't do that, but that's available on my GitHub if you wanna check it out and try. So the two repositories, and that's all the code, that's all I needed, right? The two repositories are GHA-test, that's kind of the main repo, and the other one with the fake one with the backdoor is fake-GHA. Okay? Any questions about what we saw? Okay.
What would happen if I use my account and for your project, for your repository?
Yeah.
Would I automatically start executing your workspaces in my the runner?
No, once you fork that, you run the action.
No, I'm asking if I would fork a malicious repository so that the work flow is in my organization. Would it run in my organization?
Yeah, it was going to run under your username or under your organization. But the IP address, for example, if you don't change the IP address here on this backdoor.sh, then if my machine is on and it's listening to connections, then if you run the action, so if you trigger a push event, if you change something on that repository that you just forked, then it's gonna connect back to my machine if it's listening, right? But I'm gonna shut down that machine after the demo, so after the talk, so don't worry about it. But if you wanna try your own, deploy your own EC2 instance, make it publicly accessible on 443, and then you change the IP address of that code and it's gonna connect back to your machine.
Yeah.
Sounds good? Okay.
Following this, is there an event that will trigger for repository?
Sorry, say that again?
So I can make a repository that looks legit.
Mm-hmm.
When people support it, that work will trigger automatically and run in the organization. Is there an event that will trigger the action on fork?
On fork?
Can you repeat the question?
Sure. Yeah, so the question was and please correct me if I'm wrong, is there any event that would trigger an action on a fork event or a fork repository, right? That's a good question. I'm not sure. I think I would have to check the documentation there on GitHub. There are many events there. There's a list. I use the most kind of simple ones for the demonstration, but I'm not sure there is. Yeah, I'm not sure. Okay. Any other questions? Yeah, go ahead.
The GitHub token, what is the default rights does it have in the organization?
Sorry, say that again.
The token that the runner.
The token.
Yeah.
It has, by default, it has read and write permissions in that repository. So it can only change that repo.
Across the organization.
No, it's just for that repo. Yeah. And it's only valid while the action, the VM is up. Once the VM is down, the token is gone.
Yeah, thanks.
Okay. Any other questions? Okay. Yeah, go ahead.
How deep is the rabbit hole in terms of action inside action inside action?
As many as you want. Yeah, exactly. Very, very great. Just like like a tree has many branches, and just like your libraries, right? So, yeah, same thing. Okay. Let me switch back to the slides, and I'll definitely share those later. But this is kind of the reference that I used. Kind of mostly, hopefully, show up. Mostly the GitHub Security Lab blogs, and there was some R2C .dev blogs, the developers of SemGrep, maintainers of SemGrep as well. And yeah, thanks everyone for joining. I hope you enjoyed, and I'll be available throughout the event today and tomorrow if you want to talk about it, this topic or any other topics. Sounds good? Thank you.